It is an exciting time to be part of the solid-state drive industry. We see tremendous growth, both in client and data center space, and we're really at the critical moment in solid-state drives where we're crossing from these early adopters that are aggressively embracing solid-state drives into the mainstream of IT, and that is both in terms of volume and market momentum driving us there, and in terms of the product capabilities that we're bringing in. And we've talked a little bit about that today, our third generation solid-state drives, having the features that make them the no excuses drive to drive tremendous growth into the data center with solid state. Today we're really here to talk about the data center space, and the S3500 is focused on the data center, read-intensive applications, and embedded intelligent connected devices. And in the data center, we see lots of new applications driving solid-state drives. Particularly, a lot of these new applications in cloud and big data and virtualization are driving very high random IOPS, so a lot of random activity to the solid-state drive, and solid-state drives are really good at that. They need to have the right level of performance, they need to have the right level of data security, data integrity in order to operate in the enterprise. And then in the intelligent connected systems, we're seeing that same type of activity, but we'll also see a strong desire for the robustness and long MTBF that comes with a solid-state drive when these things are positioned out in the environment and not in a highly controlled place. As we make this transition into the mainstream, we're getting an increasingly broad capability in our solid-state drive product family, both in breadth of products as well as in features within those products. So we have a broad product family. We have introduced just earlier this year the caching software, cache acceleration software, ICAS, and that is something that works with all of our enterprise solid-state drives and is validated to work with them well. And that's where people are using caching software to begin their journey with solid-state drives, and they're putting their initial solid-state drives into their application environment where they don't want to replace all of the hard disk, but they actually want to put a new storage tier in there and cache the hot data, or the most frequently used data in the enterprise. We have the 910 series product, which is a PCI add-in card form factor. We have an example back here on the side of the room for that product, and that has been a great product for that cache acceleration software. We have the high endurance enterprise product, the DC S3700 product, and that's a high endurance product that we introduced last year was our first third generation product. And then today we're introducing a new product, which is our mainstream product based on our 20 nanometer process technology. That's the DC S3500 series product for read intensive applications that gets us a lower power and lower cost point for high quality, high capable products in the data center. Some of the key attributes of the product is that it has high IOPS performance of 75,000 random read and 11.5K random write performance. It's amazingly consistent in that 99.9% of the time it has a 500 microsecond or less latency to the drive. And it's standard endurance, but there's an enormous amount of data that can still be written to this drive. So it's like it's 450 maximum terabytes written on that particular drive, and that's about the same as constantly recording high-def movies for 5.7, almost 6 years of high-def movie content could go onto that. So it's standard endurance, but it's still got quite a bit of endurance on that drive. It's got the stress-free data protections, end-to-end data protection, so that's ECC, error correction to detection, that follows the control and the data throughout the drive from the moment it enters to the moment it leaves. It's got power loss protection. That's if there's an unexpected power failure in the enterprise while you're in the middle of writing something. It has enough energy or capacitance in the drive so that it can complete any partially written commands to the drive. It can make sure that all of the writes that were intended to go to the drive complete even if power is lost to the drive. Very high quality reliability we would have expected from Intel, 2 million hours mean time between failure. We've got on our 20 nanometer process technology, we've got a broad range of capacities from 80 gigabytes to 800 gigabytes. Even in the 1.8 inch form factor, you can look at the 1.8 inch form factor back here, but it's in 2.5 and 1.8 inch form factors. And it's very cost and power efficient. We can get this with our 20 nanometer process technology down to 1.6 watts, typical operational power, and 0.65 standby power. It is our third generation of solid state drives. We started our enterprise versions of our drives in 2008 with our first generation product, the X25E. And this product recognized the need for fast, random reads and writes to storage. It was a phenomenally successful product for us, although the market was much smaller at that time, of course, and was very successful. We learned a lot from delivering that product to the marketplace and introduced our second generation of product with the 710 series, and that had even faster random performance, which we found was incredibly important for emerging workloads. But also introduced the concept of high endurance technology for more write-intense applications in the enterprise. So our third generation of product, we believe, has the right features, the right cost points, and the right capability to unleash SSDs into the mainstream of the data center. One of the things that's been obviously a huge trend in the data center is virtualization. And virtualization in the data center has been very, very good for the data center. It's improved our efficiency in the data center. Our average utilization of servers has gone way up. That's enabled us to get the rack space per server or per virtual server down. It's enabled us to get lower power per computational element in the enterprise and helped us improve the cost of the infrastructure. But what happens when we virtualize servers is we take an application that has a series of requests to storage, and those requests may be sequential in nature or they may be random in nature, whatever the element of, whatever the reflection of the application is. But when we run multiple of those servers simultaneously in a virtual server on top of a virtualized server environment, what happens is those I/O requests become interleaved. And all of the storage requests look very random and in nature. It's like an I/O blender, if you will, to requests to the storage system. So the random performance of the storage system becomes incredibly important. And it's something that solid state drives do really well. And hard disks don't do so well because they're mechanical in nature and they have to move around in order to get to those new random locations. And if you look at two drives that have the same average performance consistency, or the same average performance, you can see that they get there in very different ways. And this is, and if you look at this chart, what is it showing? What the performance looks like at any one moment in time. Sometimes it's kind of slow, and sometimes it's fast, but it averages about there. This is a sort of a typical competitive drive. And then on the right is the S3500, which has a very tight level of consistency associated with it. And that's one of the things we learned in going through our second generation of product, is when we designed a controller for this product, there's activity going on in a solid state drive at any moment in time. Background activity. So it's not just responding to a read or a write request from the compute subsystem. It is doing background activity, making sure that the drive is evenly wear level, that error corrections have been done, repositioning the drive for future requests.